So this is the poster I want to be talking about today. And I want to point you to the fact that in its file name, it has this phrase final. So before it got into its final version, there were lots of drafts, and my teammates provided quite insightful comments on each of those drafts. And towards the end, I was able to come up with something that we would all be excited about and we would be all satisfied with. So here it is. And it may seem for now that it's quite crowded and there is lots of text, there is lots of figures, and they're all quite small. But actually, if you print it on A0 sheet of paper. So each of these white panels becomes like a standalone PDF file that you can navigate through. So you can see that this poster is made using some template, and this template was actually provided by my team, which I'm also thankful for, but it's inspired by the official template from University of Cambridge. So of course there is University of Cambridge logo and the name. There's also a logo beneath those panels. And overall you see there is some structure to it that is actually quite common across different academic posters. So you have title, you have authors, you have their affiliations, and then you have panels with subsequent sections that you will be guiding your narrative through. And then of course you have a list of references that I mentioned before and the funding agencies that support your research. So let us dissect this academic poster a little bit. As I said before, I'm starting with the motivation, and I outlined the end goal of the project, which is realization of a quantum state transfer, or in other words, building a quantum memory. And then I use fancy phrases like central electron spin or central spin scenario, which are meant to just put the work in a broader context, because as you can imagine, there are multiple ways to build a quantum memory, and I need to specify which one we try to follow. And then there's this little advertisement section, which outlines all the advantages of our solution and all our recent results. But you'd be probably surprised to see that straight after that I included the section on limitations. And this is because I also want to put my specific contribution to this field in already quite a narrowed down context. The difference of what I'm doing to what we have already done is that I try to do it using different material. And this is because the old material has some limitations that we can't really go past. So in order to achieve even more spectacular things than those that we have already achieved, we need to most likely switch to this material. And then you can see that I put a lot of effort to actually describe the microscopic model that we use in order to understand the physics behind our system. And the reason I'm so meticulous about it is because the interaction that actually governs the dynamics in our system is quite a surprise. And it's quite a surprise to everyone. So lots of people will already get fascinated just by the form of it and just by the physical origin of it when I start talking about it in here. So as I said before, if your research touches on anything new or something that is not really popular among people in the research community, expose it, because it can lead to very interesting academic discussions. And then you can see that section 2 and section 3 have those square brackets with numbers in their titles. And this is because all of those contents are taken from the papers that I cite in here. So overall, I'm citing 5 papers in this academic poster, and not all of them are published by our group. So it's also common to refer to the research done by other scientists. So then, having discussed the modeling and the theory proposals together with numerical simulations, I go on to discussing the experimental data. And if you compare the area covered by those figures with the area covered by maps or text, you see that they actually take quite a lot of space. And there's a very good reason behind it. which is that the data is ultimately what matters in all of the research. So you want it to be nice and clean, such that people can distinguish all of the features you want to show them. So imagine that you chose those figures to be smaller than they are, and due to some technical errors, your printer didn't capture these two tiny peaks in here. It would be then very hard for you to convince your audience that those peaks are indeed in here, and therefore it would be harder for you to carry on with the narrative towards the next section, because the next section in my poster actually addresses the problem that this data indicates. So you want to be able to make this clean connection between panel 5 and panel 6, and for that you need your figures to look clear. So then the final section is the section about the future steps that we want to take. And as you can see, there's a design of a device that we want to manufacture, but there also is another bit of data. And now the reason we included another bit of data in here is because we don't want this final section to be just a daydreaming, just saying what we would like to do. We also want to be able to support it with experimental evidence from other research groups, and we want to make a strong case for why our ideas have a chance to work. So I hope it is clear to you now what narrative I tried to build behind this poster, and I don't claim this was the best one to have regarding a research project like this one, but it was definitely the most natural narrative for me to have about it. And because of that, when I go and talk about my research in front of this poster, I feel like it naturally supplements the flow of my ideas, and because of that I am able to maintain the clarity throughout the entire talk. And I think that's ultimately what really matters when presenting the poster. It's about how you sell it to others, because it won't sell itself, it's all about you. And if it naturally complements your inner voice, I think it's a clear prescription for a success in making people excited about the research you do. So let me now tell you a little bit more about the technical aspects of making your own academic poster. And let me start by telling you that actually universities very often provide some brand templates that you can reuse. So I searched through the University of Cambridge website and I did find a few templates. So I went for the simplest one that they had to offer. I open it and it looks like a regular PDF file. And if you want to edit it, I would recommend using Inkscape. I think this is pretty much a standard in the field. Then if you open it in Inkscape, it's just the regular editor. So I can select some areas, for example in this way, and edit the content. So let's set it to my first academic poster. And if you fancy, you can, for example, change the color to pink or, I don't know, orange. And now, if you haven't heard about Inkscape, there's a good reason to use it. It is because it can handle so-called vector graphics quite well. And you want to be using vector graphics across all your figures and across the entire poster, actually. So it's probably easiest to discuss what vector graphics is by the example. So as you can see here, I have a file that it's called not a vector graphics. So it's in PNG format. And if I open it, you see it's just a nice looking figure, but as you keep zooming in closer and closer, you see that there are visible pixels in here, so it doesn't rescale nicely. So then imagine you made your poster in a PNG file, and you printed it, and your figures didn't look smooth anymore. You want to avoid it at all costs, so you want to work with something that rescales nicely. And this is of course the feature of vector graphics. So now here I have the same figure saved as the vector graphics, and as I keep zooming in, you see that the quality stays quite nice, that all the features are sharp, there are no visible pixels, and I could actually be zooming in over and over, and this will remain in this nice sharp form. So this is why you want to work with it, and usually vector graphics will be saved in the PDF format or SVG format. Inkscape can actually handle both of them, and as I said, I think this is a pretty standard environment to use when you work with vector graphics. So if you do your research in science, then you'll most likely want to put some equations on your poster, and now I'm going to talk a little bit about that. So in research community, what we use to generate mathematics and actually entire pieces of text with mathematics embedded in it is this language called LaTeX. So it's actually supposed to be pronounced LaTeX or something like that. And this is how you spell it, LaTeX. So if you want to learn LaTeX, I recommend you going through the tutorial on the website called overleaf.com. The main advantage of LaTeX is that, as I said before, it can really generate nicely looking equations. So of course you can say that I can do the same in Microsoft Word, but at some point when your mathematics gets quite involved, LaTeX has more of a functionality, so everyone simply switched to it, and I recommend doing the same. Okay, so what I'm using to compile LaTeX is this environment called TextStudio. This works well on Windows. I'm not sure if it works well on iOS, but if you work with iOS, I have experience working with TechShop. Nevertheless, try downloading TextStudio if you work with iOS. So let me type in an example equation in here. So as you can see, this code has a very similar structure to HTML. So you always type begin and name of the section, and this one will be simply an equation. I put a star at the end because I don't want to enumerate the equations. And let's go for something simple for now. So 2 + 2 = 4. Now if I'm ready to compile the file, I just click this green arrow, build and view. This environment TextStudio has a nice feature that it shows the compiled file on the side by the code. So maybe let us put something more involved as well. Okay, so now you see the second equation I put in here, if you've touched on quantum mechanics, you will recognize that those objects are simply cats in Dirac notation. So the fact that I'm able to implement them quite nicely in here is because there are many packages compatible with LaTeX, and there's this package called physics, which is just great for all quantum researchers. So then when we generated the file, it got saved to the PDF, so we can import it back in Inkscape. So let us go to our poster, and let us now click import the file called maths. And now important thing is that you need to change the import settings to this Poplar Cairo, otherwise you'll have some problems with fonts. We want to use the original font. Okay, there we go. Here are our equations. And now if you want to select just one of them, it's probably not the most intuitive thing in Inkscape, but apparently that's the only way to do it. You have to cover the one you're interested in with a rectangle. Yeah, I know this is quite weird. And then select entire PDF you've generated. You see it's quite long because there's also the page number that I didn't turn off. And then if you have both of them highlighted, you go into Object, Clip, Set, and you're left out with just the equation you were interested in. So then if I hold the Control button and move around with arrows, you can see I can make it as big as I want, and at the same time it also rescales nicely because it's in vector graphics. So this is why I'd recommend using LaTeX together with Inkscape. Besides the text and equations, you'll probably also want to embed some figures in your poster. So regarding generating figures, people use whatever they feel comfortable with. Many of them would definitely choose MATLAB, Python, or Excel or Origin. And I use Python, and I have good reasons to do that actually. This is because Python is compatible with variety of libraries that can be very useful for very specific research purposes. And at the same time, there's a really nice library when it comes to plotting. It's called Matplotlib, and I encourage you to visit their website. There's this section where they list all the example plots they produced. And I'm sure that whatever type of data you want to illustrate, you will find something that you can very easily adapt from here. So in my case, I coded something that generates some data points, so I'm not uploading any measured data in here. And then let me run the code. And then it simply puts it on the log plot. So what I'd like you to look at is those equations that I also included. So this is, for example, the title of the plot, the x-axis label, the y-axis label. This maths is also coded using actually LaTeX. So that compatibility of this coding environment with other environments I use is a strong argument for why I think it's a good idea to use Python. So then if you want to save the figure, let's choose the folder. Remember to save it as a PDF again. And this is because, as I probably managed to convince you already, we want to really work with vector graphics. So now we can open it as a standalone PDF file. That's great. And let's import it into our poster design file in Inkscape. So we did everything as before, and here is our figure. Now, another cool thing about vector graphics and plots produced by Python is that, for example, if you don't have access to the code, but you have access to the figure and you don't like the color, you can still modify some aspects of this plot. So, for example, here I chose to work with simply this red line, and I don't like the color. So, well, let me change it to blue. There we go, it's blue now. So, and I can convince you once again that it rescales nicely under this dragging. Sorry, this was the background, so okay. As I keep enlarging it, it stays nice and sharp, and there are no artifacts, no pixels appearing. So let me now shrink it such that it fits the poster. Okay, that should be fine. We can get rid of those gray boxes in here, and now we can bring the figure here. Okay, that's great. So now we placed our figure in our poster, and it's all ready to make it nice and aligned. So with that, I'd like to conclude this mini tutorial, and I'd like to wish you all the success in your future academic presentations.